Naming organic molecules. For you to be able to name an organic molecule, you need to know how to identify the main chain. So now, the main chain is usually the longest chain in your organic molecule. And in that longest chain, you must always have the functional group. So if I can repeat what I've just said, for you to be able to name an organic molecule, you need to identify the main chain. And then the main chain is the longest chain that has a functional group. Let's say, for example, we look at the following alkane. So we know that the functional group of an alkane, it is just the single bond in between carbon atoms and also the single bonds in between carbon atoms and hydrogen atoms. So this one here is an alkane. So we can see now the functional group is in any chain we can look at. So now what we have to do is just to identify the longest chain. So when you talk about a chain, we talk about where you start from one carbon and then you move without lifting your pen. So if you have many number of carbons in that chain without lifting a pen, that is going to be your longest chain. And remember now, your longest chain is your main chain. So this chain that we have looked at, it has 5 carbons. But now we can also look at another chains. For example, we can start from here, move, and then we bend like this. But if we look at this chain is having 4 carbons. And then we can also look at another chain which we start from here and then we move like that, and it also has 4 carbons. So this will mean that the longest chain, it will be this chain that is having 5 carbons. So that is how you identify the main chain. So let us look now if ever we had an example of an alcohol. So remember now, an alcohol, it is defined by this functional group here, whereby we have oxygen and hydrogen bonded to a carbon. So this part here will actually say this, whatever organic molecule we have is an alcohol, because this is the functional group. So now, if we want to identify the longest chain, remember now, the longest chain, it must always have the functional group. So now the functional group is on this carbon. So that means we can start from this carbon and move like this. If we look at this chain, we have how many carbons? We have 1, 2, 3, 4, 5. So now we can also take another way. We say we can move like this. And then if you look at this, we have how many? 1, 2, 3, 4 carbons. So this means that the longest chain will be this chain that is having 5 carbons. And then it also includes the functional group. So now it will be incorrect if you said that the longest chain is going to be this chain. If you look at this chain here, it is having how many carbons? 1, 2, 3, 4, 5, 6. But now in this chain, we don't have the functional group. So we are not going to consider this chain as our longest chain. So remember now, the longest chain, it always has the functional group. So if you are able to identify the main chain, then you're going to come to the next step. So the next step will say now, the number of carbons in the main chain will be represented by the following names. So if you have 1 carbon in the longest chain, we're going to say that it's going to be meth. And then if you have 2 carbons, it's going to be eth. If you have 3, it's going to be prop. If you have 4, it's going to be but. If you have 5, it's going to be pent. If you have 6, it's going to be hex. 7 is going to be hept. 8 is going to be oct. 9 is going to be non. And then 10 is going to be dec. So you need to be able to memorize the following number of carbons in names. So now, remember we said now the main chain that we have is this chain in this molecule. So now we're going to say now, okay, in our main chain, we have what? We have 5 carbons. So now we're going to say now, what is 5 carbons? So 5 carbons is actually represented by pent. So we're going to say we have now, this molecule is going to be 5 carbons in the main chain. So that's going to be pent. And then one thing that we know is that this molecule is an alkane. So if it is an alkane, remember now, an alkane, it ends with what? With A and E. So that means at the end of what? Of that subscription of a main chain, we're going to put now A and E. So that means now in the main chain, we have a pentane. So the next thing that you also need to learn, it is that we have now branches. So now branches are what we have, let's say for example, you see now this carbon is extended from another carbon that is in the main chain. So this is going to be called a branch. So you will also need to name the branch. Remember now the first thing that you do, you name the main chain, and then after that you name the branch. So now if you name the branch, you should label your longest chain from the side whereby the branch it is closest. So you're going to say, for example, you can choose your longest chain to start from here, which is going to be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Or you can also select your main chain to start from here to say this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So in this case, it really doesn't matter which direction you take, because you see now the branch is attached to a carbon that is on what? On position number 3 of the main chain. So now whether you take this direction or whether you take that direction, you are going to have the branch of this carbon attached to carbon number 3. So now in front of naming the main chain, you're going to now include now the branch. So now in this case, if you look at the branch, on the branch we only have what? We only have one carbon. So we're going to say now this one carbon, it is actually a branch that is in the third carbon of the main chain. So you're going to say now we have on the third carbon, we have now this one carbon. And then remember now, one carbon, it is represented by meth. So you're going to say now you have 3 methyl. So now if you look at the branch, you must change the ending to say now it is methyl. So we're going to have 3 methyl, but now remember the longest chain is what? Is pentane. So the whole name of this organic molecule is going to be 3 methyl pentane. So now if we were to also label this alcohol, we're going to now select our longest chain. Remember now we have selected the longest chain to be this chain here that has the functional group. So this is going to be our longest chain. So now if you are dealing with what? With functional groups such as alcohols, aldehydes, ketones, carboxylic acid, and esters, you need to always give now the functional group preference when you number your chain. So that means now your chain will start whereby your functional group is starting, it is closest. So in this case, we're going to say from now, the chain will have what there? 1, 2, 3, 4, 5. So now we're going to name it in this way because what? The functional group is closest to this carbon if we go into this direction. So remember, I said now on alkanes, we actually name what? Whereby we have what? The closest branch. We take the direction whereby we have the branch closest to the carbon. But in the functional group like alcohols, we give the functional group a preference, whereby the functional group, if is in the first carbon here, we're going to choose the direction and then we're going to move in this way. So now, if we look at what we have, we're going to say now, on our main chain, we have how many carbons? We're going to have 1, 2, 3, 4, 5 carbons. So if we want to label this alcohol, we're going to say this alcohol is having 5 carbons. And then if you look at this, 5 simply means bent. So we're going to put now bent. But now, because this thing here, it has a functional group of alcohol, we must put now to say now this is pentane, and then we also must label the position of the carbon in which that functional group is. So do you see now this functional group of OH is in the first carbon. So we're going to say now we have now pentane, and we have 1, and then we have all. So now the ending part of alcohol is OL. So that means now this longest chain is going to be pentane 1 all. So you need to specify that it is in position number 1. Okay, so now we also have now the branch here. So now how do we name this branch? We can see now at this branch here, we have 2 carbons. So we know if we have 2 carbons, the branch is going to be ethyl. So now, which carbon in the main chain is this branch attached to? So the carbon is going to be the second carbon. So we're going to name this to say now this is 2, but now remember now this chain is having 2 carbons. So it's going to be what? It's going to be ethyl. And then we have that main chain, which is pentane 1-O. So that is how we usually name organic molecules. So now, in this video, we are going to name different types of organic molecules so that we can get used to how we name organic molecules. So the first organic molecule that we're going to look at is what we call alkanes. So if you look at this first alkane here, we are having just a straight chain that is consisting of 5 carbons. So remember now, for you to name an organic compound, you must identify the main chain. And then in this case, the main chain is having 5 carbons. So we're just going to say now, or that main chain is going to be pentane. Remember now, 5 means pent. And then if you look at alkanes, we just take the last part, which is just going to be pentane. So now in this case, we don't have any branches. That means the name of this compound is just going to be pentane as it is. But now, if we look at this second molecule, we are going to see that we can have now, or we can select the longest chain. So remember, when you talk about alkanes, the longest chain is just the chain that is having many number of carbons, because now you can look at it in this direction. That is going to be the longest chain, and you can also look at it in this direction. So now, if we have identified this as our longest chain, so remember now, we can name our chain from what? From going to left to right, or from what? From right to left. So we're going to say this is carbon number 1, this is carbon number 2, carbon number 3, carbon number 3, carbon number 4. And then we can also go in backwards to say this is 1, 2, 3, and 4. If you do this, you will see now this branch here, it is closest when we label the main chain when we move from right to left. So that means now we're going to label it moving from right to left. So now these names that we have written here of going to the right, we can just erase them. And then we can now start to label this organic molecule. So we will say now on the main chain, we have 4 carbons. So remember now on the main chain, if we have 4 carbons, we are going to say now we have what? We have but. But now because this thing is an alkane, we're just going to end it as what? As butane. And alkane always end with A and E. So now we must look at now the position of which we have the branch. So now the branch that we have is situated in what? In carbon number 2 of the main chain. So we're going to say now in carbon number 2 of the main chain, we have the branch. But now what is the name of this branch? This branch is only having 1 carbon. So remember, if you have 1 carbon, it's going to be methyl. So now the name of this organic molecule is going to be 2-methyl butane. If we also try to name the following organic molecule, we will also have to do the very same thing. The first thing, we identify the longest chain. So now this can be our longest chain. This can also be our longest chain. This can also be our longest chain, because now any chain that we choose, we are having 3 carbons. So now we can just select now this chain here to be our longest chain. So if we have selected that as our longest chain, we're going to label it from left to right. So say now we have what? We have 1, 2, 3. And we can also label it from right to left. We have 1, 2, 3. So now remember, we give preferences to what? To the branches. So now in this case, we can see now the branches are situated in carbon number 2. So whether you start from left to right, so it is always in carbon number 2. So it doesn't matter which direction you take. You will still going to name it the same way. So the first thing that we do, we identify the longest chain. So now the longest chain, it is having 3 carbons. So now if we have 3 carbons in the longest chain, remember 3 simply means prop. But now because we are dealing with alkanes, this is going to be a propane. And then now, if we look at the branches, we have now two branches that are actually situated in the same carbon. So we're going to label now to say now we have a branch on carbon number 2 and another branch on carbon number 2. So now those branches, because it's two of them, we're going to say this is di, since they are the same. So you have a branch on carbon number 2 and carbon number 2. And then we're going to name it what? A di. And then remember now this branch, it is having one carbon. That is going to be a dimethyl. So the name of this organic molecule is going to be 2,2-dimethyl propane. So that is how you will label all these following organic molecules, which are alkanes. So now, something that we also need to learn, it is what we call an isomer. So when you talk about an isomer is something that has the same molecular formula. In this case, we can say now it has the same general formula. Remember now when you talk about alkanes, the general formula is given as CnH2n plus 2. So you will see now for all these molecules, if you substitute now the number of carbons that you have in it, in this case, the first one we have 5 carbons, you are still going to get the same molecular structure. So now the structure of what? Of the first compound is going to be 5 carbons. And then remember now the number of hydrogens is going to be what? You say 2 multiplied by 5, that is 10. 10 plus 2, that is going to give you 12. Okay, so now that will happen to also this type of an alkane, because in this alkane, what matters is the number of carbons we have. And then we have how many? 1, 2, 3, 4, and 5 carbons. So we're going to have now the same thing to say now, even organic molecule number 2, it is having the molecular formula as C5H12. And then the same thing will happen to the last one, because it is having 5 carbons. Remember, if you put it in what? In the general formula, you will substitute now the number of carbons is 5, and then the number of hydrogens will be 12. So now an isomer is organic molecules that have the same molecular formulas but different structural formulas. Do you see now in this case we have different structural formulas, but all these alkanes, they have the same molecular formulas. So we call that an isomer. So an isomer, it is when we have the same molecular formulas but different structural formulas. So we have 3 types of isomers. So now these 3 types of isomers are named what we call now a chain isomer, and we also have a position isomer or a positional isomer, and then we have now a functional isomer. So now in this case, if you look at what we have here, what is changing, it is actually the chain. Remember now, the longest chain was having 5 carbons. And then if you look at now this chain here, it is having 4 carbons. And then this chain here, it is having 3 carbons. So do you see now all these things, they have the same molecular formulas, but now they have different chains. So that means now all these isomers here, they are going to be chain isomers. So that is how we identify a chain isomer. So now when we talk about a positional isomer, we talk about whereby we're going to change now the position of the branch in this case. Let's say, for example, we're having the same alkane, but now the position of the branch is moved from carbon number 2 to carbon number 3 and something like that. That will mean that we have what? A positional isomer. And then if we talk about a functional isomer, this is whereby we have the same function but moving from one carbon to the other carbon. So that will be what? That will be the positional isomer if we move the functional group from one carbon to the other carbon. But now, if now we start to change the functional group, that is going to be a functional isomer. You will understand this as we move on to another types of homologous series. So the second type of homologous series that we need to know how to name, it is what we call now an alkene. So remember, the first thing that we do, we identify the longest chain. And then in this case, we can clearly see now the longest chain is just going to be this chain. So now, if you look at this longest chain, we have now the functional group. Remember now, the functional group, it is where we have now 2 double bonds between carbons. And that functional group, it identifies alkenes. So now, we're going to say now our longest chain is going to be this chain. So now, how many carbons do we have in the longest chain? We have 5 carbons. So now we're going to name now 5. Remember now, 5 simply means bent. But now, if you look at this, what we have is an alkene. So now this alkene can move from this position to that position, to that position, to that other position. So now, remember now, we must label our what? Our longest chain based on where the functional group is. So you can see now the functional group is closest on this side. So that means our chain is going to be 1, 2, 3, 4, 5. So now we must now mention now the functional group at the end of the longest chain. So we'll say now the functional group is in position what? Is in position number 1. So we're going to say now we have pent, and then that is on position number 1. And then that functional group is an alkene. So an alkene, it ends with E and E. So that means you're going to have pent 1 in. So that will be the longest chain of this alkene. And then this longest chain will be the name of this alkene because it does not have any branches. So that is how you will name an alkene. So now, if you look at the second alkene that we have to now identify the longest chain. So remember now, the longest chain that you choose, it must always have the functional group. So now we can choose now this chain here, which is having 4 carbons, or we can also choose this chain here that is having 4 carbons. But now we can't choose this chain here because it has 3 carbons and also it does not have the functional group. Let's assume that we choose the longest chain to be this chain. So now we're going to label our longest chain whereby our functional group is closest. So now if we move from left to right, we can say we have 1, 2, 3, and 4. And then if we move from right to left, we have 1, 2, 3, and 4. So now we can see now, no matter whatever direction we come, this functional group, it is always going to be found from the second carbon. So it doesn't matter which direction we take. So now what we're going to say is that because this is an alkene, we're going to say on the longest chain, we have 4 carbons. And then remember now, 4 carbons simply means what? We have boot. But now we need to identify the position of the functional group, which is an alkene. So now in this case, the position is going to be what? In the second carbon if you come from this side, and then also in the second carbon if you come from that side. So that means the functional group is on carbon number 2, and then that functional group is an alkene. So we end with E and E. So now we have labeled what? The main chain. So now after we have labeled the main chain, we have to now label the branches that we have. So we can see now the branch that we have here, it is actually on what? On the second carbon if we come from this direction. But now look, if we come from this direction, this branch, it is now on the third carbon. So if this functional group is in between, that means we should give now the side that is having the branch closest a focus. So that means now our longest chain is going to be this chain that is moving from right to left, because now the branch is closest to this next carbon, since the functional group, it is balanced whatever direction we take. So now we're going to name now the branch to say now this branch is attached to the second carbon of the main chain. So that is going to be what? That is going to be 2. But what is going to be the name of that branch? This branch is having 1 carbon. That is going to be a methyl. So the name of this organic molecule is going to be 2-methyl-but-2-N. So that is how you will name that particular alkene. So now, if you look at now this last alkene that we're looking at, we have to identify the longest chain. So remember now, the longest chain should always include the functional group. That means we can say the longest chain is in this way, which we have 4 carbons, or we can also say the longest chain is in this way, which we have now 4 carbons. So whichever longest chain you take is going to have 4 carbons. So now we can take this as our longest chain. But now remember, we always give preference to where the functional group is. So that means we were going to name this from this carbon here. We say this carbon 1, carbon 2, carbon 3, carbon 4. So now if we have a particular direction, we should name it in that particular way. So now we're going to now label what? The main chain. So now if you look at the main chain is having how much? Is having 4 carbons. So now remember, 4 carbons simply means what? Simply means boot. But now, where is the position of the functional group? So the position of the functional group is actually in the first carbon. So now we're going to say now this is boot 1, and the functional group is an alkene, so we're going to end with E and E. The last thing that we need to identify now is if we have branches. So now we can clearly see now we have branches. So now this branch is attached to the third carbon. Since we have already named this from what? From the functional group. Remember now, you can't say now you choose it from what? From where the branch is closest. No, you have to select from where the functional group is closest. So now that means this branch here, it is actually on carbon number 3 of the main chain. So we're going to say now the branch is attached to carbon number 3, but that branch is having 1 carbon, so that is going to be a methyl. So the name of this organic molecule is going to be what? 3-methyl boot 1N. So remember now, we also said, we talked about isomers. So we said all these things here are alkenes. And then we know that alkenes have the following general formula, CN2H2N. So for the same number of carbons, if you look at this alkene here, we have 1, 2, 3, 4, 5 carbons. And then in this one, we have 1, 2, 3, 4, 5 carbons. And then also in this one, we have 1, 2, 3, 4, 5 carbons. So that means now for an alkene, the general or the molecular formula is going to be for 5 carbons. And then we have now 2 multiplied by 5, that is going to be 10. So for all this, they're going to have now the same molecular formula. But if you look at all these, they have different structural formula. So these things are isomers since they have the same molecular formula but different structural formulas. But now, what type of an isomer do we have? So if we were to look now in between these two molecules, we can see now this is a what? Is an isomer. But now this isomer, it is actually a positional isomer, since now the functional group was positioned here and then it is now positioned on this carbon, which is the second carbon. So do you see now this is going to be a positional isomer. It is a positional isomer because the position of the functional group was shifted. And then again, this is also going to be another a chain isomer, because now remember, now we had on the longest chain we had 5 carbons, and then on this chain we had 4 carbons. So this is a positional isomer and it is also a chain isomer. So if we look at these two molecules. So now you can also look at this molecule and that molecule, and then you will identify the very same thing. You will see now we have now a positional isomer, because now the functional group, it was on the first carbon, it is now on the second carbon. And then we can also say now we have what? A chain isomer, because now we don't have a chain isomer since we have what? Since we have the same chain, which is 4 carbons. So what we have is only what? The positional isomer, but now the chain is just going to be the same chain. So now the position of the functional group has been shifted from carbon number 1 to carbon number 2. So that means we're going to name that a what? A positional isomer. Is a positional isomer because the functional group has been shifted. We can also say it is a positional isomer since now, if you look at this now, we have now the branch being moved to what? To carbon number 2 to now carbon number 3. But now if you look at it from this point, this branch, it is still on what? On carbon number 2. So do you see now the position of the branch, it is still the same. But what makes it to be an isomer is the position of the functional group. So that is how we will deal with isomers in alkanes. So now the next thing that we need to look at is alkynes. So if you look at alkynes, remember, for us to be able to name whatever organic molecule, we need to identify the main chain. So if you look at this chain, we just have one chain that is having what? That is having 5 carbons. And then in this chain, we also have the functional group. So we're going to name now the main chain. To say now, the main chain, it is having 5 carbons. Remember now, 5 carbons simply means bent. And then now when you talk about bent, we have to also identify where is the position of what? Of the functional group. So remember, you always label it for the carbon that is closest to the functional group. So this is carbon number 1, 2, 3, 4, 5. So this is the direction that we will pick because now this functional group is closest when we come in this direction. So now we're gonna say now we have bent on the main chain, but now the position of the functional group is in position number 1, and then that is gonna be an alkyne. So now remember, an alkyne, it ends with what? With Y and E. So now we have what? We have pent 1 in. So that is that is how we label now an alkyne. So now, if we move on now to the second alkyne, we're going to say now, okay, we have to now select the longest chain. So if you look at this, this is going to be our longest chain because it's the only chain that we have, and it has 5 carbons, and then also it has what? It has the functional group. So now this is our longest chain. So remember now, if we have identified the longest chain, we need to label our carbons closest to where the functional group is. So do you see now, if we move from left to right, and then also if we move from right to left, we see now the functional group is actually closest to the second carbon as we move to the right. So that means now we're going to take this as our direction of the functional group. So now to name this molecule, we're going to say now we have what? We have 5 carbons in the main chain. So that is going to be what we call now a bent. But now the functional group is what? Is on the second carbon. Remember now it's closest on the second carbon. So you must say now this is on the second carbon, and that is an alkyne. So we're going to end it with what? Y and E. So if you look at the last alkyne here, we're going to say now, we're going to identify the longest chain, and then the longest chain will always have what? The functional group. So now we can say now the longest chain is going to be this one that is having 4 carbons, or we can say it is this one that is having 4 carbons. But now, even if this chain, it had longest chains, we were not going to select it since it does not have the functional group. So now we can either choose this as our longest chain, or the other one is our longest chain. So now when we label now this thing, we're going to say now, we're going to give preference to the functional group. To say now the functional group is closest to this. So this is going to be the carbon 1, carbon 2, carbon 3, carbon 4. So now if we name now this alkyne, we're going to say now we have what? In the main chain, we have 4 carbons. And then if we have 4 carbons, we say now that is but. And then we also have to identify the position of the functional group. So that position is attached to the first carbon, and the first carbon is just going to be 1. Remember now the functional group is alkyne, so we're going to end with Y and E. So if we look at this now, we have now a branch. So that means now we must also include the name of the branch. So now this branch is attached to the third carbon in the main chain. So to name that branch, we're going to say this is a third carbon on the main chain, but now it is only a branch is only having 1 carbon, so that is going to be a methyl. So the name of this molecule is going to be what? 3-methyl-but-1N. So also again, if you look at all these molecules, we are going to say these molecules are isomers. Since remember now, alkynes have the same functional group, which they have now the same functional group and also the same general formula. Then the general formula is given as CnH2n minus 2. So now for the same number of carbons, we are going to get the same molecular formula. So if we substitute now for 5 carbons, we're going to say now we have 5 carbons. And then now to get the number of hydrogens, we're going to say 2 multiplied by 5, which is 10, and then we minus 2, that is going to be 8. So now this molecular formula is going to be the same for all these organic molecules. So we're going to say now all these organic molecules are what we call isomers, since they have the same molecular formula but different structural formulas. So now if we can look at now these 2 molecules, can we identify which type of an isomer we have? If we look at this, we have now the same chain, which is now 5 carbons. So that means it's not going to be a chain isomer. But now, if we look at now the position of what we call now our functional group, it has shifted. That means in between these two molecules, we are going to have a positional isomer. It's a positional isomer because the functional group has shifted. Okay, but now if you look at these two molecules here, we can see now we have the main chain as 5 carbons, but in this case, the main chain is 4 carbons. So, but now, if you look at this, we have now the functional group also in different position. So we can say now in between this thing, we have now what you call the positional isomer, and we also have the chain isomer, since we have now different main chains. So in between these two molecules, we have a positional isomer because now the functional group, it has shifted from different carbons, and then now the chain, which is the main chain, it is also has changed. So now we have both functional and positional isomer. I mean, now we have both positional and chain isomers. So now if we move on now to the next type of organic molecule, which is now haloalkanes. So haloalkanes are the trickiest one, but now we should always treat haloalkanes as alkanes. And then if we look at halogens, we just treat halogens as branches. Okay, so now you will understand what I just said. So if you look at this, we're going to first identify what? The longest chain. But now remember, the longest chain, it must always have the functional group. So now we can see now the functional group is a halogen there. So that means that carbon there, it is including the functional group. So in this case, we're going to say the functional group is the branch. We're going to treat it the same way as if like we are having branches of 1 carbon or maybe branches of 2 carbons. So that means now we're going to give the position to the branch. So now we're going to name it from this carbon moving on this way, because now the branch is closest if we move in that direction. So if you look at this, we're going to look at the main chain. The main chain, it is having how many? It is having 5 carbons. So now if you look at a haloalkane is just an alkane. So that means if you label it, you're just going to say you have what? You have now a main chain, you have 5 carbons. So that is just going to be a pentane. So it is always going to look like a what we call now an alkane. So we're going to now label this as if like it's a branch. So if you look at this branch here, it is on the first carbon. So we're going to say now on the first carbon, we have this branch. But now the name of this branch, remember now we have bromine. So if you write it as a branch, it's going to be bromo. So this is going to change to now be bromo, 1-bromo pentane. So that is how you label a haloalkane. So now let's look at this particular haloalkane, whereby we have to now identify the longest chain. So remember now the longest chain must always include the functional group, in which in this case is a halogen. So now if you look at this, we have 4 carbons, and then if you look at this, we also have 4 carbons. So whatever functional chain we choose, that is going to be correct. So now we can select this as our main chain. So now, if we label this, we're going to look at where the branch is closest. So now, look at this. We are not giving a preference to the halogen. We are giving preference to the branch. So this halogen here is the branch. So in this case, we're going to name it from where we have the closest branch. And then in this case, the branch is going to be in this one. It's going to be 1, 2, 3, 4. So we treat the halogen as a branch. We not treat it as a functional group. Remember now, if we had different types of alkynes, alkenes, we had to give preference to the functional group. In this case, we don't give a preference to the functional group, which is a halogen. We give preference to the branches. So now this halogen, we treat it as a branch. So now we're going to name now our what? Our main chain. So the main chain, it is having 4 carbons. That means we're going to say now that is butane, because we know that it's going to be a haloalkane, and an alkane always ends with A and E. So now we have to now name our what? Our branches. So now it is very much important when you name your branches, you always start with the the smallest alpha. For example, you name them in an alphabetical order. So if you look at this branch is bromo, and then this branch here is going to be meth. So that means now you're going to start with this branch. You're going to start to name this branch. So you're going to say now you have what? 1 bromo, because bromo is the closest alphabet. And then now you're also going to name now another branch, which is this branch here. And that branch is methyl. So now that methyl is in position number what? Is in position number 3. So we're going to say now 1 bromo, 3 methyl butane. So that is how we will name this haloalkane. So now, if we look at now this particular type of what of a haloalkane, let me just try to shift this halogen here. Yeah, but now if I shift it, it won't make any difference. But now remember now, a halogen, you just treat it as if like it's a branch. If this halogen was on this part here, you're going to name it from that side or that side. It really doesn't matter, because now the closest branch is just in whatever direction you take. So now, if we look at this part here, we're going to choose now the longest chain. So now the longest chain is going to be the chain that is having what? The functional group. In this case, the functional group is a halogen. So now we're going to see now we have 3 carbons here. We have 3 carbons if you move this way, and we also have 3 carbons if you move this way. But now you cannot select this as your main chain since it does not have the functional group. And then in this case, the functional group is a halogen. So now we're going to select any chain. For example, we can say now this chain here is our main chain. So now if we name now this main chain, we're going to say now, okay, where do we have the branch closest? Remember now, this is a branch. We're not going to treat it as if like it's a functional group. We don't give the functional group a preference. We give the branch. So now this is a branch, and then this is the branch. So now, do you see now the branch is closest on this branch here, which is going to be now the bromo. So we have 1, 2, 3. So that means now at the closest branch, that is where we give the direction of the main chain, and then we treat the halogen as what? As a branch and not a functional group. I will make one example whereby we have that a branch of a halogen not being the main branch. So now, if you look at this, we're going to have now 3 carbons in the main chain. So remember, if we have 3 carbons, we call that a propane, because this is an haloalkane. We know that alkane is just going to be propane. So now, what is the position of the branches? We have now the branch here, which is bromo, and then bromo, it is first alphabet before we can put now these methyls. So we're going to start to name the bromo. We're going to say we have 1 bromo, and then after that, we're going to look at what? We have now these 2 branches, which are what? Which are called methyls. So remember now, these methyls are what? Are 2 of them. We're going to say 2, 2. And then we say that is a what? That is a di, because now it is 2 of them. So it's a dimethyl. So the name of this haloalkane is going to be 1 bromo 2,2-dimethyl propane. So that is how you will label that organic molecule. So now remember, we have now the same what you call this molecular formulas for all these different things, because they fall under the same homologous series. So that means they have the same general formula. And then now the general formula of halogens is given as Cn, and then we have now H2n plus 1, and then we have now the X there, which represents the halogen. So if you wanted to identify the molecular formula of each of these following compounds, you are going to substitute now the number of carbons you have. So you see now you have 5 carbons in all these different structures. You see now it's 5 in the main chain. Here we have 1, 2, 3, 4, 5. Then also here you have 1, 2, 3, 4, 5 carbons. So we will just substitute now the number of carbons, which is now 5 carbons. And then now your hydrogen is just going to be 2 multiplied by 5, which is 10. And then you have to plus it with the 1 there. So that means you're going to have 11 hydrogens. And then now you must also indicate the halogen you have. In this case, it's just going to be a bromo. So that means now this will be the molecular formula of all these haloalkanes. So now they have now the same molecular formulas, but they have different structural formulas. So we call these things isomers. So now what type of isomers are these? If we can look at these two here, we'll say now the type of isomers that are this is going to be what? If you look at this, the main chain is just going to be what? Is a 5 carbons, and then the main chain now is 4 carbons. So do you see now the functional isomer that we have there is a chain isomer, because now the chain has shifted. The main chain has changed. Okay, so now if we look now at the position of the bromo, it is just still on what? On the first carbon. So that means now the only isomer that we have now is a chain isomer. So now if we can also look at this and that, we will see now we have now in the main chain we have 4 carbons, and then in the main chain we have 3 carbons. So that means we also have now a chain isomer, since we have different chains. And then if you look at this now, again, this bromo is on the what? Is on the first carbon. So that means now the position has not shifted. But now if this bromo was, for example, shifted to another carbon, then we're going to have now the positional isomer. So we only have what? The chain isomer in this case. So now if we move on now to talk about alcohols. So if we name alcohols, remember, we always look at the main chain, and the main chain must always have the functional group. So now in this chain, the main chain is going to be this chain here, because since it is the only chain that we have. So if you look at this chain, it is having 5 carbons. But now when you talk about alcohols, you always give preference to the functional group. So now your OH is your preference. It doesn't matter if you have the branch closest, you always look at the carbon that is having what? That is having the OH, the functional group. So you can see now the functional group is closest on this side, so that means we'll label it from 1, 2, 3, 4, 5. So now if we name an alcohol, we can see now on the main chain we have 5 carbons, so we know 5 simply means pent. But now because this is an alcohol, you can't say you have pentol, so that means you must put it as what? As pentane, and then you put now the position of the alcohol. The alcohol is in position number 1, so it is a pentane 1-ol. So it is very much easy to pronounce it as pentanol. So now if you just pronounce it without this AN, it is going to be very much difficult for you to pronounce it. So you need to add this AN when you label the main chain of an alcohol. So if you look at this second alcohol, we have to identify the main chain. So we can say now the main chain is this chain here, because it has 4 carbons, or we can say now the main chain is that chain. So now we can just select now this as our main chain. And then now we're going to give what? We always give preference to the functional group. So that means now the carbon that is closest to the functional group is the one that we're going to start with. So we're going to say we have 1, 2, 3, 4. In this case, it doesn't matter where the branch is. We give preference to the functional group. So now once we have identified the main chain and then we have labeled it accordingly based on where the position of the functional group is, we can start to name the alcohol. So now remember, now on the main chain we have how many? We have 4 carbons. So 4 carbons simply means but. But because it's alcohol, we're going to say butane. And then now what is the position of the functional group, which is OH, is in position number 1. So we're going to say 1 and then we say ol. So we have butane 1-ol. So now, if you look at this, we now have a branch. So that means now we must also include the branch. So this branch that we have is what? Is a meth. So now, what is the position of that branch? Is in position number 3. So we're going to say we have 3 methyl butane 1-ol. So that is how we will label this organic molecule. So lastly, if we look at this alcohol, we're going to also look at what? At the main chain. So we're going to say now the main chain is a chain that must have what? That must have the functional group. So now we can say now the main chain is this chain here, because now this carbon here is having the functional group, and then also the main chain is this chain here, because the carbon is having the functional group. So now if you look at this, how do we name this? We're going to say now, okay, we're going to select this as our main chain. But now if we have selected that as the main chain, we can clearly see now wherever we label now our chain, we will see now the functional group is on carbon number 2. So it really doesn't matter where we label it. So in this case, we're going to now start to do what? To name our what? Our main chain. We're going to say now the main chain, it is having 3 carbons. So if it is having 3 carbons, it's going to be what? It's going to be prop. But now because it's an alcohol, it's going to be propan. And then where is the position of the functional group, which is alcohol, is in position number 2. So it's going to be propan to all. But now we also have now a branch in carbon number 2. So now what is the name of that branch? The branch is in carbon number 2, and then it is named a methyl. So that means the name of this molecule is going to be 2-methyl propan to all. So that is how you will name this organic molecule. So if you look at this, we have now this molecule and this molecule as isomers, since they have what? The same molecular formulas. But now if you look at this, this is not going to be the isomer with those other ones, because now it has 4 carbons, and then these other ones, they have 5 carbons. So now this one here, it is not going to be an isomer. Remember now, when we talk about the isomer, we must have what? The same molecular formula. And then remember now, an alcohol, it is given as what? As the general formula of Cn, and then we have H2, and then now we're going to say now we have 2N, we have +1, and then we have now the OH. Okay, so that is going to be the general formula of an alcohol. Remember now, we have just replaced one hydrogen with OH, so that is why we have that as a functional group. So now if we wanted to determine the molecular formula of these 2 compounds, of which now they have 5 carbons, remember now you're going to just say we have now 5 carbons, and then now the hydrogen is going to be how much? It's going to be 2 multiplied by 5, which is 10 plus 1. That's going to be 11 hydrogens. And then now you have that hydroxide. So this will be what? This will be the chemical formula of both these alcohols. But now, if you wanted to look at the chemical formula of this alcohol, you're going to have something different. So that means now the molecular formula will be having now 4 carbons. Remember now you have 1, 2, 3, 4 carbons in the chain. So now you're going to have 4 carbons, and then you're going to substitute now 2 multiplied by 4, which is 8, plus 1, that is going to be 9, and then you have OH. So do you see now the molecular formula is going to be different. This is going to have different molecular formula from these 2. So this is not an isomer to these 2. But now these 2 are isomers. But now what type of isomers are these 2? If we look at this, we can clearly see now the chains are not the same. So we can just say now we have what? A chain isomer. So now if you look at the position of the alcohol is on the same carbon. So that means it's not a positional isomer. It is only a chain isomer, since we are not having the same main chain. So we're going to move on now to another type of homologous series, which is called an aldehyde. So now when we label or name the aldehyde, we always look at what? At the main chain. And now the main chain must always have the functional group. So remember now, the functional group of an aldehyde, it is a double bond oxygen on the last carbon, because now the functional group is a double bond oxygen and hydrogen must be on that carbon. So this is only on the last carbon. It is always on the last carbon. Okay, so now we can see now the main chain is going to be this chain here. And then if we look at this, we're going to give what? We're going to give the functional group the preference. So remember now, this is going to be carbon number 1. We have carbon 2, carbon 3, carbon 4, and carbon number 5. So now when we name the aldehyde, we're going to name the aldehyde to say now on the main chain we have how many? We have 5 carbons. So 5 carbons simply means bent. And then now what is the position of what? Of the functional group. So in this case, you don't have to put the position, because the position of the aldehyde, it is always going to be on the first carbon. So this is just going to be a pentanal. Is going to be pentanal. So remember now, you just put penten, and then you put now then the al. So for aldehydes, you will never see now you have pentane 1 something, on our pentane 2 something. So if you start to have that, that is not going to be an aldehyde. An aldehyde, it is always ending with Al, because the functional group is either on the first or the last carbon. So now, if we look at the second molecular formula, we can name it by now identify the longest chain. So the longest chain can be this chain because it contains of what? The functional group, or it can also be this chain. So we can now select the longest chain to be this chain, which is having 4 carbons. And then now, remember, we always give preference to the functional group. And we can see now the functional group is here. So this is 1, 2, 3, 4. So when we label now this aldehyde, we're going to say now the aldehyde is having how many carbons in the main chain? It is 4 carbons. So now the name of this is just going to be what? It's just going to be a butane and then butanol. Because now we know it's an aldehyde, it is always going to be a butanol. It's not going to have any particular position. So now you will also have to now label the branch. So now you can see now the branch is on what? Is on the 3rd carbon, because we always give preference to the functional group. So now this branch is on the 3rd carbon, so it is going to be 3, and then the branch is a methyl. So the name of this compound is going to be 3-methyl butanol. Then if you look at this last one of an aldehyde, we have to identify the longest chain. So the longest chain can be this chain because it has 3 carbons, and it can be this one, and it can also be that one. So whatever chain that you choose, remember it must always have the functional group. So I'm just going to select this as my longest chain. So now remember now, when you have the longest chain, you always label it from where you have the functional group. So in this case, we're going to start with this carbon. This is 1, 2, and 3. So do you see now, if you label now this aldehyde, on the main carbon you have 3 carbons. So this is going to be what? This is going to be a propanol, because we know it is an aldehyde. So the position of this functional group, it is always going to be on the first carbon. So we don't have to name it. We just always say that is a pentanol. Okay. So now if you look at this, we have now 2 branches that are attached to the same carbon. So we're going to say now we have 2, and that is going to be what? It's going to be a dimethyl. So that is how we will label that organic molecule. So we're going to say now this is a 2,2-dimethyl propanol. Okay, so now if you look at all these aldehydes are going to be isomers, because if you look at them, they all have 5 carbons. And then remember now, the equation for an aldehyde is given as what? As CN, and then we have H2N. So remember now, if you look at this oxygen here, it is replacing 2 hydrogens. So that is why we move those 2 hydrogens, and then we're going to have now oxygen there. So now for 5 carbons, the general formula is going to be 5 carbons, and then we're going to have how many hydrogens? 2 multiplied by 5, which is just going to be 10 with 1 oxygen. So this will be the molecular formula for all these aldehydes, since they have 5 carbons in them. So that means now they have the same molecular formula, but different structural formulas. So they are called isomers. But now, what type of isomers are these things? So if you look at this, in between this, we're going to have what? We're going to have now a chain isomer, since the main chain, it is not, it is now different. So we're going to have what? We're going to have now the chain isomer. And then if we also look at this, we're also going to have what? A chain isomer, since the main chain, it is not the same. So remember now, for aldehydes, you cannot have the positional isomer, because now this functional group, it is always on the same carbon. So you cannot have the positional isomer. You only have what? The chain isomer on the aldehydes. Okay, so now the next thing that we will look at, it is what we call now ketones. So now if we look at ketones, ketones have the similar relationships with aldehydes. But now a ketone, it is having an oxygen on a carbon that is bonded to other carbons. So it is not on the last carbon. So now if you name the ketone, you must identify now the longest chain. So now we can clearly see now the longest chain is this chain here. And then we are always going to give the preference to the functional group. That means you're going to label it from here to say this is 1, 2, 3, 4, and 5. So if you look at this, we have 5 carbons in the main chain, but now remember now this is the ketone. So that means you're going to say now we have what? We have 5 carbons. That means that is pentane. And then now you must position where is your functional group. So now your functional group is on the second carbon. That is going to be 2, and then that is going to be 1. So that means that is a pentane 2, 1. So that is how you will name that ketone. In this case, this ketone does not have any branches, so that will just be the name of it. So now if you look at now the second ketone, we can clearly see now the longest chain can be this one, or it can be this one, since they have the same carbons, which is 4 carbons in the main chain, and they contain what? The functional group. So now remember now when we label, we always give preference to what? To the functional group. So you see now functional group is closest on this carbon. So we will label it from this one, say 1, 2, 3, 4. That is how we will label the chain. So now when we name this, we're going to say now the main chain, it is having 4 carbons. So now remember now if we have 4 carbons, you're just going to say that is butane. And then what is the position of that ketone? The ketone is on position number 2. So that's going to be 2, and then we write now 1. So that means it's going to be butane 2, 1. So now we can see that we have what? A branch. So if we have a branch, we also need to include that branch in a name. So now this branch is attached to carbon number 3. So that is going to be A3, and then the branch is a what? Is a methyl. So the name of this molecule is going to be 3-methyl butane 2, 1. So now if you look at this last molecule here, we can see now the longest chain, it is going to be this chain here. Because now there is no other chain. It is only this chain that is having what? 5 carbons. So now we can say now this is our longest chain. And then now it doesn't matter where we label it, because now we can clearly see now this functional group is in between. We can come from this way, we say 1, 2, 3, 4, 5, or we can come from here, we say 1, 2, 3, 4, 5. We can clearly see now the functional group is on what? Is on the third carbon. So now if we were to name this, we're going to say now, okay, the main chain, it is having how many? 5 carbons. So that means now we're going to have what? We're going to have pentane. But now what is the position of that ketone? Is in position number 3. So that's going to be 3, 1. So we label it as what? As pentane 3, 1. We don't have any branches. So now if you look at all these things are going to be isomers, since they have what? Since they have the same molecular formula. So now the molecular formulas of this is going to be what? The same molecular formula as an aldehyde. So in this case, it's going to be CN, and then we have H2NO. So for 5 number of carbons, we're going to have now 5 carbons. And then hydrogen is going to be 2 multiplied by 5, which is going to be 10. And then we have that oxygen. So do you see now, we have now the same molecular formula, but we have different structural formula. So we can identify now the type of an isomer in between here. To say now the type of an isomer is a chain isomer, since the main chain, it is not the same. So we can say now in between there, we have now a chain isomer. But now if you look at this and that one, the first one and the second one, what we have now the same chain, but now we have now the different position of what? Of the functional group. So that means now this one is going to be what? A positional isomer. Positional isomer. Okay, so now this is what is most important now. If you look at this, if you look at a ketone and aldehydes, both the ketones and aldehydes, they have now the same general formula. Both the ketones and aldehydes have the same general formula. So in this case, if they have now the same molecular formula, but now they have different functional groups, we are going to refer to them as what? As functional isomers. For example, if you look at this and that, that's going to be a functional isomer. Any of the aldehyde that is having 5 carbons and then any of the ketone that is having 5 carbons is going to be a functional isomer to the aldehyde or the ketone. So now, if we move on now to now name a carboxylic acid, we're going to say now, if we want to label the carboxylic acid, we're going to look at what? At the main chain. So now remember now, the main chain is the main chain that contains the functional group. And then the functional group of a carboxylic acid is this oxygen bonded to a hydroxide on one carbon. Okay, so now if you look at this, the main chain that we have how many? We have 5 carbons. So now if we name now the carboxylic acid, we're going to say now, because we have 5 carbons, that is going to be what? That is going to be a pentanoic acid, because now the functional group of what? Of carboxylic acid is always on the last carbon, so you don't have to put the position. So in this case, we're just going to have what you call now a pentanoic acid, since we have now 5 carbons. So this is going to be pentanoic acid. So that will be the name of this carboxylic acid. So if you also look at this carboxylic acid, we can now select this main chain because now it has the functional group. We can say now this is our main chain. So remember now, we are always going to have what? Whatever on the main chain, we're going to have, in this case, we have now 4 carbons. So automatically we can name that as what? As butanoic acid. So we're going to say now this is going to be a butanoic acid. Okay, but now remember now, if we look at this, we have a branch. So now for us to label the branch, we're going to give the preference to the functional group. So now the functional group is on the first carbon, so we have to label it from 1, 2, 3, and 4. So we can clearly see now the branch is on the 3rd carbon. So we're going to say now this thing is going to be what? Is going to be 3-methyl, is a 3-methyl butanoic acid. So that is how we will label that second carboxylic acid. So now if you look at this last carboxylic acid, we can clearly see that we have now the functional group starting from this carbon. It can be this way, which means it has what? It has 4 carbons, and it is the only way that it will be, because this is the only way that has what? That has 4 carbons, and then this way it is only having 3 carbons. So this means now the main chain will be this chain here. Okay, we must just include that. Okay, so now remember now, if we have the main chain having 4 carbons, we already know that we're just going to have what? A butanoic acid. But now, if we have to now label the branch, we will give preference to the functional groups. The functional group is starting here, so we have 1, 2, 3, 4. So we can see now the branch is attached to the second carbon of the main chain. So that means we're going to have now this as what? As 2-methyl butanoic acid. So that means the branch is on the second carbon. Okay, so if we look at all these are going to have also the same molecular formula, because carboxylic acid have the same general formulas. So for the same number of carbons in the molecule, that means you're going to have the same molecular formula. So now the molecular formula of a carboxylic acid, we're going to say now this is what? This is going to be a CN. Then we have H2N. Remember now we have now replaced what? We have replaced 2 hydrogens and then another hydrogen. So that means that is going to be -1 in this case. And then we have what? We have 2 oxygens and 1 hydrogen. So but now if you look at a carboxylic acid, this hydrogen here, we're going to replace it with this -1. So the general formula of carboxylic acid is CnH2n, and this -1 will cancel that oxygen, and then we have O2. So this will be the general formula of carboxylic acids. So now for the same number of carbons, we're going to get the same general or the same molecular formula. So now if we have 5 carbons, it's going to be 5 carbons, and the number of hydrogens is going to be 2 multiplied by 5, that is going to be 10, and then we're going to have now 2 oxygens. So this will be the same for all this type of molecules. Okay, so now you see now all these type of molecules are having the same molecular formulas, but now they have what? They have different structural formulas. So we're going to consider them as isomers. But now if you look at this isomer and this one, we can clearly see now that is going to be a chain isomer, since we are having what? The longer chain has 5 carbons and then the longer chain has 4 carbons there. So we're going to say in between these two, we have what we call now a chain isomer. But now if you look at this one here, we are having the same chain, which is 4 carbons and then 4 carbons. But now, if you look at now the position of the branch, it is different. So now we're not going to say now that is a positional isomer. When you talk about the positional isomer, we talk about the position of the functional group. So now in this case, we're going to say now we have now a chain isomer there. And then if we move on to the last part, which is esters, we will see now if we talk about esters, esters will also have the same general formulas as what? As carboxylic acid. So let's say, for example, the general formula of carboxylic acid, it was CnH2nO2. So you can clearly see now a carboxylic acid and esters are functional groups. Functional isomers. So now, how do we now label an ester? First, before we can label an ester, we need to identify that an ester, it is made of a carboxylic acid bonding with an alcohol. So let me just quickly show you this reaction. Let's say, for example, we have now the following carboxylic acid, a carboxylic acid that is having, we can say 3 carbons. And now on a carboxylic acid, at the last carbon, we have this type of bonding. And then if this thing is bonding with an alcohol, let's assume now this alcohol is just only having 2 carbons, and then on this branch it has now its functional group of alcohol. So now what is going to happen is that when this carboxylic acid is bonding with this alcohol, you will see now this part here whereby we have OH and the other OH, they are going to make the bond. But now, when they make the bond, we are going to take away the water, which is now H2O. So that means now we can cancel this hydroxide and this one oxygen. And that means now on the products, we are going to have now one product as H2O. Because now this thing here will be water. And then now if you look at that, we're just going to join this carbon here to this oxygen, and then we're just going to have something like that. So this means now the ester that we're going to have is just going to be now these 3 carbons on the carboxylic acid. And now they're going to be bonded to this oxygen that will connect them. So this oxygen is also bonded to that carbon there. And then it's going to have something like this. And that will be how you actually acquire an ester. So now this is very much important when you name the ester, because you need to know now which part is a carboxylic acid and which part is an alcohol. So in this case, we know that this part here, it is going to be an alcohol. So this part here, which is not having a double bond oxygen, is going to be an alcohol. And then we start to name the alcohol. So in this case, we can see now this alcohol, it is having 2 carbons. So we're going to say now, okay, the alcohol is having 2 carbons. So that is just going to be 2 carbons simply means eth. So that is going to be ethyl. That is how we name the alcohol. And then now the second part, we are going to now name what? We are going to name the carboxylic acid. So now we can see now the carboxylic acid is having what? 3 carbons. So if it is having 3 carbons, we're going to name it as what? As a propanoid. So this is going to be ethyl propanoid. Propanoid. Yes. So this is going to be ethyl propanoid. Yes, propanoid. So that is how we will label this ester. We first label now the part that is attached to an alcohol. We just look at the number of carbons. So if it is 2, we know 2 means ethyl. And then now we look at the part that is attached to carboxylic acid, which is this one that is having double bond. How many carbons is that? It's going to be 3. So it's just going to be a propanoid. Okay, so now with that being said, that means we can be able to label the following molecules of esters. So if you look at this, we can clearly see now this part here, it is coming from alcohol, and then this part here, it is coming from carboxylic acid. So the first thing that we do, we name the part that comes from alcohol. So from alcohol, we have how many? We have 2 carbons. So that is going to be ethyl. And now this part that is having a carboxylic acid is having 3 carbons. So that is going to be ethyl propanoate. Propanoate. Okay, so that is how you will label that. Okay, so now if you look at the second part here, what we have is that we have now this chain here. Do you see now this chain that is having an ester? An ester we identified whereby we have carbon with 2 oxygens and to another carbon. So now that means we can select now our longest chain. To say now we have this as our longest chain. So now, what is going to be our longest chain? If you look at this, we're going to name now our longest chain. To say now on our longest chain, we have this part here as a carboxylic acid and this part here as an alcohol. But do you see now this alcohol here? It is actually having a branch. So now you're going to look at this alcohol. And then now from that alcohol, you will say now, okay, you have now, you're going to label it from this point to say you have 1, 2, and then now for carboxylic acid, you will label it from this point, 1, 2. Okay, and then you can also label the alcohol from this point, 1, 2, and then you can label carboxylic acid 1, 2. So now we can clearly see now on this carbon here that is attached to the part of alcohol, we are having a chain. So that chain is going to be in position number 1, in position number 1 of the carbon that is bonded to the chain. So we're going to say now this is just going to be 1, and then we're going to say that is a methyl. So that is going to be 1 methyl. And then now we name the carbon after the alcohol. The alcohol is what? Is ethyl because it has 2 carbons. So it's going to be 1 methyl, and then we're going to have now ethyl, which now represents the carbon. So we have 1 methyl, ethyl, and then now if you look at this part, we have a carboxylic acid. So if we name the carboxylic acid, we can see now the carboxylic acid is consisting of 2 carbons. If it consists of 2 carbons, it is going to be ethanoate. So it's going to be a 1 methyl ethyl ethanoate. Ethanoate. Okay. So that is how you will label that ester. So now if you look at this last part of ester, we can see now we have this main chain. And then if you see now at the part of the alcohol, we don't have any branch. But now on this part of a carboxylic acid, we have a branch. So now we're going to now label what? The part of the alcohol. Because we always start with the part of alcohol. And this part of the alcohol is only having 1 carbon. So if it has 1 carbon, that means it's going to be what? It's going to be a methyl. Okay, and then if you look at the part of carboxylic acid, remember now when you label it from what? From the chain, and then you say now the functional group is starting here, so it's going to be 1, 2, and 3. So when we name this, we're going to say now, okay, we know that we're going to have now the longest chain as 3 carbons. That means that is going to be a propanoate. So we know that we're going to have what? We're going to have a propanoate. Propanoate, and that propanoate, it is having now a branch, and then this branch we can clearly see it is attached to the second carbon. So you're going to say now the branch is what? It is 2-methyl, and then you have propanoate. So the name of this is going to be what? Methyl 2-methyl propanoate. So now this methyl that is standing alone, it represents the alcohol, and then this methyl here next to the carboxylic acid, it represents the branch of the carboxylic acid. So now all these things here will be isomers. Remember now it will depend now which type of an isomer they are. So in this case, if you look at this, we have now the longest chain, which is now in this case, we can see now the chains are going to be different, because now if this is the longest chain, it is having 5, and then this is the longest chain, that is having what? It is having 4. Okay, so now the chain is different. And then if you also look at this, then we're going to have now 4 carbons. That means it has the same chain as that one. Okay, so that means now we just have now the chain isomer in between these 2 esters. Okay, but now what is important is that you need to know that in between an ester and a carboxylic acid, you have now functional isomers. So do you see now these two things, they will have what? Remember now, the carbons that we have here is how many? Is 5 carbons. That means the general formula is going to be 5 carbons. And then we have now 2 multiplied by 5, which is 10. And then we have oxygen 2. We are going to get the same molecular formula for different functional groups, which is a carboxylic acid and esters. So therefore, that is going to be the functional isomers. This will be functional isomers. So remember, we get the functional isomers between carboxylic acid and esters, and we also get a functional isomers in between aldehydes and ketones. So these are also functional isomers. Yes, I'm going to end here with this video. Thank you very much.